Hello students, today we will start chapter 13, Sound. Sound plays an important role in our lives. It helps us to communicate with one another. We hear a variety of sound in our surroundings. The sound that is produced by the vehicles, the sound produced by birds, animals, then musical instruments, etc. How is this sound produced? Sound is produced by vibrating a body. Then what is this vibration? The to and fro or back and forth motion of an object is called vibration. For example, when you pluck a tightly stretched rubber band, it vibrates and produces sound. When it stops vibrating, it does not produce any sound. Now we can see some more activities to show that sound is produced by a vibrating object. Here, see the picture. A boy is striking a pan. Take a metal plate or a shallow pan. Hang it at a convenient place in such a way that it does not touch any wall. Now, strike it with the stick as shown in the figure. Touch the plate or the pan gently with your finger. Do you feel any vibrations? Yes. We feel the sensation of vibration on the finger. Again, strike the plate with the stick and hold it tightly with your hands and immediately after striking. Do you still hear the sound? No. When the pan is held tightly with the hand after striking it, we cannot hear the sound. Now touch the plate after it stops producing sound. Can you feel the vibration now? When we touch the plate after it stops producing sound, there is no sensation of vibration on the finger. Listen to another activity. Take a rubber band. Put it around the longer side of a pencil box as shown in the figure. Insert two pencils between the box and the stretched rubber. Now what you have to do is plug the rubber band somewhere in the middle. Can you hear the sound? Yes, we know that it produces the sound. Does the rubber band vibrate? Yes, the rubber band also vibrates. Then what will be your conclusion then? A vibrating body produces the sound. See the next activity. Take a metal dish. Pour some water in it. Strike it at its edge with a spoon. When you strike it with the help of the spoon, you can hear the sound. Again strike the dish and then touch it. Can you feel the dish vibrating? Yes. Again, when we strike the dish and touch it, we feel that the dish is vibrating. Now strike it again and observe the surface of the water. Can you see any waves there? Yes, some waves are seen on the surface of the water. Now hold the dish. What change do you observe on the surface of water? When we hold the dish, some of the waves disappear and we feel vibration in the hand. Okay? So from this it's clear that the vibrating object produces sound. And in some cases, the vibrations are easily visible to us. Now, see the picture here which is shown. This is a musical instrument which is called ek tara. So how to make it? Take a hollow coconut shell and make this musical instrument called ek tara. We can also make it with the help of an earthen pot, and we can play this instrument and can observe the vibrating parts. Now see the next one. This is also a musical instrument which is called as jal tarang. How to make a jal tarang? See that. Take 6 to 8 glasses or tumblers. Fill them with water up to different levels. That can be increased gradually from one end to the other. Now take a pencil and strike the glasses gently. You can strike all of them in succession. That means in different levels. We have arranged them in the increasing order of the water level. And when you strike it, you can hear the pleasant sound. And that is your jal tarang. So this jal tarang is a plate type of musical instrument. And here a low level of water in the glass, it produces low pitch sound, whereas a high level of water that produces a high pitch sound. Now, sound produced by humans. Now, when you speak loudly for a while or sing a song and you keep your finger on your throat, do you feel any vibrations? Yes, we can feel it. While talking, if you keep your hand on your throat, you can feel the vibration there. In humans, the sound is produced by voice box or larynx. So when you keep your finger on the throat while speaking, we can see a hard bump that moves, or we can feel a hard bump that seems to move. And this part of the body is known as the voice box. And this voice box is the upper end of the windpipe. 2 vocal cords are stretched across the voice box or larynx in such a way that it leaves a narrow slit between them for the passage of air. So the figure is shown there, the voice box which is found in humans. And when the lungs force air through the slit, the vocal cords vibrate. And you know that a vibrating object produces the sound. When this vocal cord starts vibrating, it produces sound. The muscles attached to the vocal cords can make the cords tight or loose. So the vocal cord can be made tight or loose with the help of the attached muscles. And when the vocal cords are tight and thin, the type or quality of voice is different from that when they are loose and thick. Now, sound needs a medium for propagation. That means for the travel of sound, it needs a medium. That means sound can travel through different media like solid, liquid and gases. It cannot travel through vacuum. Now, for that, listen to the activity that is shown there. That will prove sound needs a medium to travel. Take a metal or glass tumbler. So, that tumbler that you have taken, it should be dry. Place a cell phone in this tumbler. Then you can ask your friend to give a ring on this cell phone from another cell phone. So you can hear the ring, you can hear the sound of ringing. Now, what you have to do is surround the rim of the tumbler with your hands. That means cover it with your hands. Put your mouth on the opening between your hands. So keep your hands on the rim of the tumbler and put your mouth on the opening between your hands. Then ask your friend to ring again. Then listen to the ring while sucking air from the tumbler. That means what you have to do is you can listen, the phone will be ringing. By that time what you have to do is suck air from the tumbler. That means the amount of air in the tumbler, it goes on decreasing. By that time you have to listen to the ring. Does the ring become fainter as you suck air? That means as you suck air, whether the volume, whether the sound of the phone that is ringing, whether it becomes less or not. Remove the tumbler from your mouth. Does the sound become loud again? That means once you remove the air, what happens to the sound? And again, what you have to do? Remove the tumbler from the mouth. Then listen to the sound. Initially, you know that the loud sound of the cell phone will be heard. And as the air was sucked from the glass, the sound of the ring became fainter since the amount of air decreased in the glass. The process of sound propagation got slowed down and the sound became fainter. When the amount of air reduces in the glass, the produced sound becomes fainter. As we remove the glass from the mouth, air enters the glass and the sound becomes louder. That means when the glass is completely filled with the air, the cell phone ring is heard loudly. As the air decreases in the glass, the sound becomes fainter. This shows that the decreasing amount of air in the glass has direct relation with the loudness of sound. Then what will be your conclusion from this activity? Sound needs a medium to travel. Air is also a medium. When all the air is removed from the glass, there is vacuum in the glass. So sound cannot travel through vacuum. That's the reason why we cannot hear any sound in the moon, or we cannot hear any explosions that takes place in the sun from the earth, because between the earth and the sun, to a certain distance only there is air. Afterwards it's vacuum. So we cannot hear the explosion taking place in the sun. See this activity to show that sound travels through liquid. Just now what you have seen, sound can travel through air. Air is a medium. Now sound travels through liquid. For that, take a bucket or a bathtub. Fill it with clean water. Then take a small bell in one hand. Shake this bell inside the water to produce sound. So the bell does not touch the body of the bucket or the bathtub. Place your ear gently on the water surface as shown in the figure. Can you hear the sound of the bell? Yes, we can hear the sound of the bell. And this shows that the sound can travel through water or liquids. Now listen. What is this which is shown in the figure? It's a toy telephone. Have you ever made a toy telephone? Then how to make a toy telephone we can see. Take 2 paper cups. Make a small hole at the bottom of both the cups with the help of a pin. Then take about 10 meters of long thin string. Pass the thread through both the holes and tie it with the cups. Place one of the cups near to your ear and give another cup to your friend. You can ask your friend to go away from you so that the string becomes stretched and tight. Now, tell your friend to speak in front of the cup. You can listen the voice of your friend through the cup near to your ear. That means hear the sound it travels through the string. Is that clear? Sound can travel through air, liquids and solids. Now, how do we hear the sound? We know that we hear the sound through our ears. And the shape of the outer part of the ear is like a funnel. And when sound enters into the outer ear, that's into this funnel, it travels down through a canal at the end of which a thin membrane is stretched tightly. And this is called eardrum. So what is the eardrum? The thin membrane which is present in the ear, that is the eardrum. And this eardrum, it performs an important function. So what is the function that is performed by the eardrum? See, here the model of an eardrum it is made, how it can be. See, take a plastic or a tin can and you can cut its ends. Stretch a piece of rubber balloon across one end of the can and fasten it with a rubber band. Put 4 or 5 grains of dry cereal on the stretched rubber. So now if you say something, if you ask your friend or anybody to say something from the open end as it is shown in the figure, and then observe what's happening there. We can see that when you speak, the grains will start moving. You can see the grains jump up and down. So why this happens so? Because when you speak, there will be vibrations. So due to the vibrations of the rubber sheet, grains are jumping up and down. So the eardrum is just like this stretched rubber sheet. Sound vibrations make the eardrum vibrate and thus we can hear the sound. So what will be your conclusion from this? When sound falls on the rubber sheet, and here in case of our ear, the rubber sheet, that is the eardrum, it starts vibrating. This is how the eardrum works. Okay, see this here it is shown the structure of the human ear. Eardrum it is shown there. Okay, then what is eardrum? It's the thin membrane which is found in the ear, that is the eardrum. And here it is. The eardrum is like a stretched rubber sheet as we have already seen it in the activity. And the sound that is produced, it makes the eardrum vibrates. And then the eardrum sends this vibration to the inner ear. And from there, the signal goes to the brain. So the ear has two parts, which are three parts. The outer ear, the middle ear and the inner ear. And when this signal that goes to the brain, we can hear the sound. Is that clear? Now, next topic, amplitude, time period and frequency of a vibration. We have seen that The to and fro motion of an object is called as vibration. And this motion can also be called as oscillatory motion. And you have already learned in earlier classes about oscillatory motion and its time period. And this number of oscillations per second is called frequency of oscillations. That means how many oscillations are made by an object in 1 second. This is called frequency of the oscillation. And the frequency, it is expressed in a unit which is called hertz. And the symbol is Hz. For example, frequency of an object is called as 50 hertz. What does it mean? The object has made 50 oscillations or vibrations in 1 second. That's why the frequency is 50 hertz. A frequency of 1 hertz is 1 oscillation per second, isn't it? That means if an object oscillates 20 times in 1 second, what will be the frequency then? As I told, 20 times the oscillations are made in 1 second. Therefore, the frequency is 20 hertz. Okay. Now, what is amplitude? Amplitude and frequency are two important properties of any sound. So, amplitude and frequency are two important properties of any sound. And time period, what is time period? Time period and frequency, they are reciprocals. That means the time that is taken to make one oscillation, this is called the time period. If time period, it is mentioned with capital T and frequency with F, we can write T is equal to 1 upon F or F is equal to 1 upon T. That is, time period is equal to 1 upon frequency or frequency is equal to 1 upon time period. That's what I told you. They are reciprocals to each other. Now, what is loudness and pitch? Loudness of a sound is proportional to the square of the amplitude of the vibration that produces the sound. For example, if the amplitude becomes twice, the loudness increases by a factor of 4. So, loudness is in direct proportion to the square of the amplitude. So, amplitude is twice means the loudness that increases by 4. The loudness is expressed by a unit called by the name decibel. Above 80 decibel, the noise becomes physically painful. So here in the table, what is given is some idea of the loudness of sound coming from various sources. That's our normal breathing. It's of 10 decibel. But see, in a busy traffic, 70 decibel, and an average factory 80 decibel. The loudness of sound depends on its amplitude. When the amplitude of the vibration is large, the sound produced is loud. And when the amplitude it is small, the sound produced is very feeble. And the frequency determines the shrillness or pitchness of a pitch of a sound. And if the frequency of vibration is higher, then we say that the sound is shrill and a higher pitch. If the frequency of vibration is lower, the sound it has a lower pitch. For example, a drum. A drum, it vibrates with low frequency. Therefore, it produces a low-pitched sound. But on the other hand, a whistle. Whistle has a high frequency and therefore it produces a sound of higher pitch. So a bird, the sound made by the bird, it is having a high pitch, but the lion, the sound having low pitch. That means when the lion it is roaring, it is a low pitched sound. But you know that the roar of the lion is very loud, but the sound that is made by a bird, it is quite feeble. Is that clear? Now, every day we hear the voices of children and adults. Do you find any difference in their voices? Usually the voice of a woman, it has a higher frequency and is shriller than that of a man. So certainly there is difference. Now we can see what are audible and inaudible sound. So whether the sound is audible or inaudible, that depends upon the frequency of the sound. And we know that to produce sound, an object should be vibrated. Then can you hear the sound of all the vibrating objects? The frequency of vibration, if it lies between 20 Hertz to 20,000 Hertz, then only the sound is audible to us. That means the audible frequency of sound for humans, it is between 20 Hertz and 20,000 Hertz. And if the sound is having a frequency less than 20 Hertz or above 20,000 Hertz or 20 kilohertz, it is not audible to human beings. They are inaudible sounds. And on the higher side, I told you it is 20,000 Hertz, that is 20 kilohertz. Then what is the range of frequency for human ear? It is between 20 Hertz to 20,000 Hertz. And some animals, they can hear sounds of frequencies higher than 20 Hertz. For example, dogs, they have the ability of hearing sound waves having frequency above 20,000 Hertz. And the police use high frequency whistles, which dogs can hear but humans cannot. And this sound having a frequency more than 20,000 Hertz, known by the name ultrasonic sound. But the sound waves having frequency less than 20 Hertz, it is called infrasonic sound. So humans, we cannot hear infrasonic and ultrasonic sound waves, but some animals and insects, they can hear it. Now, what is the difference between noise and music? What is noise? The sound that is not pleasant to our ears, or the unpleasant sound, which is called as noise. Where the sound that is pleasing to our ears, that is called music. So the sound that is produced by musical instruments, they are very pleasant to hear, pleasant to our ears or pleasing to our ears. They are called music. But the sound produced by the vehicles, that is a continuous horning of the vehicles, that is not pleasant. That's an example of a noise. Or sometimes you must be knowing that some construction work that is going on nearby. So the sound that is produced by the machines, so that is called noise. Is that clear? You can find out more examples for noise and music. What is noise pollution? Sounds of the vehicles or the explosions, including the bursting of crackers, machines, loudspeakers, etc. So, these are examples of noises, isn't it? So, the pollution which is caused by this noise, it is called noise pollution. Otherwise, presence of excessive or unwanted sounds in the environment, that is called noise pollution. So you must have learned about air pollution. What is air pollution? The presence of unwanted gases and particles in air, it is called air pollution. Same way, noise pollution means presence of excessive or unwanted sounds in the environment is called noise pollution. And the major causes of noise pollution, I told you, sounds of vehicles, the explosions including bursting of crackers, machines, loudspeakers, etc. And our home, television and transistor radio at high volumes, some kitchen appliances, desert coolers, air conditioners, they all contribute to noise pollution. And when you go out, that means in public places, the vegetable market, railway station and bus stand of big cities. These all are examples for the causes of noise pollution. Now, there are certain harms for this noise pollution. It is harmful. What are the harms caused by noise pollution? It may cause many health related problems. Lack of sleep, hypertension or high blood pressure, anxiety and many more health disorders may be caused by noise pollution. A person who is exposed to a loud sound continuously may get temporary or even permanent impairment of hearing. Then, how can the noise pollution be controlled? Or there are certain measures to limit noise pollution. The first thing what we have to do is control the sources of noise. And how can this be done? All noisy operations must be conducted away from any residential area. That means, how can this noise pollution be controlled in a residential area? All noisy operations must be conducted away from any residential area. The noise producing industries should be set up away from such areas. Use of automobile horns, that should be minimized. TV and music systems should be run at low volumes. Trees must be planted along the roads and around buildings to cut down on the sounds reaching the residents, thus reducing the harmful effect of noise pollution. And in general, I told you how to control the noise pollution. The first thing, we must control the source of this noise. And for that, silencing devices must be installed in aircraft engines, transport, vehicles, industrial machines and also home appliances. This is all about chapter sound. So here what we have learned in this chapter, it is how sound is produced. And sound, it travels through different mediums like solid, liquid and gases, and sound cannot travel through vacuum. Then sound which is produced by humans, then audible sound, inaudible sound, then difference between noise and music, and what is noise pollution and what are the sources of noise pollution and how it can be controlled. I hope the topic is clear to you. Read the textbook clearly and understand it. Thank you.